Maybe you just say the answer out to me. For first one,
No change.
no change. Why is it no change?
Because they're moving at the same speed.
Very good, because they are moving at the same speed, and that means relatively
They cancel off.
they are not getting away or getting closer to each other. They move at the same time. So you don't cut the B field at all. Right? If think about again the knife or the scissor move together with the string, you can't cut anything. Right? So in this case, no change, or you may say no. How do you say the word when the needle move like this? Deflection. Very good. So you can put no deflection. Number two, if now the magnet is moving towards it, then what will you say?
It will deflect.
Yeah, there will be deflection. Do you know the direction? Do you know direction, positive or negative? Actually, in this question, no. Unfortunately, because they didn't tell you positive or negative. So if I say this is positive, this is negative, then you can figure it out. But I guess IGCSE they don't want to ask you that difficultly, so they just get rid of this. So if you only say deflection in the Mach millivoltmeter, that will be good enough. Let's say if I do really give you the direction, can you tell me what direction? Would it be positive or negative? Can you figure it out? Positive. Should the current go into the positive or current go into the negative? Maybe I ask you this. Into negative. Do you all agree?
Yes.
Okay, let me check. Okay. This going down, right? So according to what law? Lenz's law. Very good. L-E-N-Z. Lenz's law. That's this side, this coil itself would want to become a magnet, and they will want to make this as what pole?
North pole.
North pole. Very good. To repel the change. Right? So in this case, you have to use hand rule, right hand grip rule to have the thumb pointing upward, and you grip like this. So in this case, you grip, yes, you have this going down. So at the end, you are correct, going to the negative terminal.
If it goes to the negative term, is it like positive? Is it like?
Depending on the design, actually.
It is like positive and then negative.
What do you mean? Usually, if you connect to the negative terminal of a voltmeter, they show you a negative voltage.
If the current goes to the negative.
Yeah. Yeah. Because if you remember, when you learn about circuits, let's say this is a light bulb, this is a voltmeter, this is positive, this is negative. You should connect this, well this doesn't matter for light bulb, but this side you should connect to the positive side. You should, right? So that it shows you a positive reading. And if you somehow connect this side to a negative, it will go opposite. And you know our voltmeter can't read the negative number. No, actually all voltmeter can't read the negative number with the analog, those kind of meter. So that's why we usually say the correct way is to connect positive on this side. So it will show you a negative reading if you do it this way. Next part. Now if the coil moving up, what will you say about this?
That will also be deflection.
Yeah, also be deflection. That's it. If you pay attention enough, you see this is something about exam skills though. 2 points here. The previous are 1 point each. So apparently you need to write something more.
And it moves closer to the
Same as previous, as in what? Very good. Same direction. Very good. I don't know whether the magnitude will be the same because I don't know the speed. If the speed, of course, is the same, then the current or the voltage would also be the same. But at least the direction will be the same.
But because in the previous figure, the magnet goes down and
Yeah.
this on the bottom part goes up.
Yeah. So relatively, it's the same. You see, right? The relative motion. Like now, if I walk close to Keith, if he cannot see anything else in the world, only seeing me, it's the same as he getting close to me. It's a relative idea,
Yeah.
right? So this is the same idea. If the magnet going down, it's the same as the coil going up, relatively. So same direction as previous. Lastly, the last one is quite easy actually. You just need to say, suggest 3 things you can increase the magnitude. So can you tell me what it could be?
Faster speed of movement.
Yeah, faster.
As the magnet moves towards the coil faster.
Right, faster speed of movement maybe.
Stronger magnets.
Stronger magnets.
More coil turns.
Very good. More turns of coil. Are you okay with that? Very typical. So this one is something that surely you want to get it right because it's just so straightforward. More force. What do you think? You think so? Stronger force. What force are you referring? Pushing the thing? Then it will be same as faster speed. And this is more direct. Any question about this? If not, we go to the next question. Can you help me to pause and start again?